All right, ladies and gentlemen, we are back with exam 3. So let's do a quick little rundown. So graphs of sine and cosine, we've graphed before. It's pretty much just normal graphing, but instead of like plotting points, now we're plotting like angles and like heights, I guess. So this is building off of the unit circle from like last exam. Pretty like straightforward, I hope. I can go over it again though. So inverse trig functions, applications of trig, it's like the same thing. So verifying trig identities, some difference formulas for sine and cosine, double angle formulas. So this is this chapter or this exam is like really heavily like memorization focused. So like we have a lot of formulas to memorize. If you guys remember the trig identity stuff from last exam, it's like sine squared theta plus cosine squared theta equals 1. We're doing a lot of stuff like that. It's like not really word problems, but like kind of word problems. It's a lot of pattern-based stuff, so we'll get into that when we get there. Trig equations, law of sines, and law of cosines. So we're dealing a lot with like triangles. Well, this is all triangles, but like this one's like we're actually drawing out like different triangles and diagrams. So yeah, just prepare for a lot of that. With that being said though, that's pretty much a pretty quick like rundown of what we're doing here. So with that being said, good luck on your exams, and I'll see you there. Peace. All right, so this is sections 8.1, 8.3, 7.2. All right, so we are doing question 3. This is what are the exact value of whatever it is. So let's go and do 3a. I'm gonna do all of them, but let's do 3a first. So we have here cosine inverse of cosine 7 pi over 6. Okay, so in regards to like inverse trig functions, we're always dealing with some sort of like range or like domain, right? So let's write it on this board, I guess. So for cosine inverse, right? So let's go ahead and draw out the unit circle here. So for cosine, our domain falls between 0 and pi. So anything here. So this is our positive side, this is our negative side. With sine inverse, we have another unit circle. Our domain falls between there. So this is going to be pi over 2 on top here, and negative pi over 2. Yeah, positive pi over 2, negative pi over 2. So this is our positive side, and this is our negative side. So remember, right, cosine was like our x's, and sine is our y's, right? So, and then for our tan, oh wait, I guess I'll write it out. So 0 to pi, brackets, negative pi over 2 to pi over 2, bracket, and tan, unit circle again. So tan follows along with sine, right, with pi over 2 and negative pi over 2. But for tan, if we remember like what tan is like sine over cosine, right? At pi over 2 and negative pi over 2, we have undefined. So here, our domain is actually negative pi over 2 and pi over 2, but in parentheses instead, because we do not have like actual values at like these angles. So coming back to over here, right, we see the cosine inverse of like this whole thing. So let's go back to here. Cosine inverse is, what's our domain again? It is from 0 to pi. So I know I might have said like when we see like cosine inverse and like a cosine here, we just kind of cross it out. The problem with that here, right, is that we're left with 7 pi over 6. So if I were to draw out 7 pi over 6, right, so let's go over here, unit circle. 7 pi over 6 falls like over here. And what quadrant is this again? This is quadrant 3, right? But look at over here, look at our domain, right? We have what? 0 to pi. 7 pi over 6 does not fit within that quota, right? So we're kind of like, it's a little iffy now. So what I recommend you to do is like take it piece by piece instead. So we always start with parentheses first, right? So cosine of 7 pi over 6. So we know that it's like quadrant 3. So what do we know about quadrant 3? Like what's the values of like sine and cosine or cosine sine? So here we have what? We have a negative x and a negative y. So negative, negative, right? So let's think about 7 pi over 6. What is his like parent like angle? It's pi over 6, right? So what's cosine of pi over 6? So cosine pi over 6 is equal to what? If we remember, if you guys like this one, I did like sine 1, 2, 3, cosine 3, 2, 1, right? So the 3 represents our pi over 6. So I know that cosine pi over 6 is just 3 over 2, or square root 3 over 2, right? But in quadrant 3, I have a negative negative. So here, this becomes like this, if that makes any sense, right? So now, if I know that cosine of 7 pi over 6 is equal to negative square root 3 over 2, right? What I can do now is bring this down. So I'm left with cosine inverse of what? Of negative square root 3 over 2. So now the question becomes, right, at what angle is cosine equal to negative square root 3 over 2? So now we go back to this guy, right? Our domain is 0 to pi. So basically, where is cosine negative in this quota? We see on the graph or the diagram I just drew out, right, that cosine is negative past pi over 2. So this means that our angle is somewhere in quadrant 2. And since we start off with a pi over 6, like derivative, I guess, pretty much our angle is going to be like pi over 6 somewhere in quadrant 2, right? So if we look back at the unit circle, what's the only pi over 6 like equivalent angle in quadrant 2? It would be our one and only 5 pi over 6, if that makes any sense. If I draw out the unit circle, right, we have 1, 2, 3. This is 2 pi over 3, 3 pi over 4. This is 5 pi over 6. Yeah, that makes sense. So our only like pi over 6 angle is 5 pi over 6. So this is equal to 5 pi over 6. I know it's a lot. It gets a lot easier with like just knowing like the unit circle, like the back of your hand. I know it's a lot to memorize, but it really helps just knowing like all this stuff like by heart, because look at me, I just drew out like 4 different things for one problem, and this is the easy one too. So like yeah, so just try to like at least know like the angles in the vicinity and like what quadrants they're in, what they represent, blah blah blah. And yeah, so moving on to 3b, we have sine inverse of sine of 2 pi over 3. Again, right, so we have a sine inverse and a sine. So if I were to cross these two out, right, I'm left with what? 2 pi over 3. Looking back at this guy, right, my quota is, or my domain is what? Negative pi over 2 to pi over 2. Where is 2 pi over 3? 2 pi over 3 falls in between that quadrant 2, right? So not in our domain. So again, we got to work backwards here a little bit. So let's start in the middle, right? So sine of 2 pi over 3. What do we know about quadrant 2? Draw this out, right? So quadrant 2. What do we know about them? This is a negative cosine and a positive sine, right? So sine, so positive here. So we can rewrite this as just sine of pi over 3, right? So what's sine pi over 3? Let's go back over here, right? Pi over 6, pi over 4, pi over 3. Boom, 3, right? So my cosine, or my sine here, is square root 3 over 2. Positive because why? We have a negative cosine and a positive sine in quadrant 2. Boom, right? So now we can rewrite the question as just sine inverse of what? Square root 3 over 2. Going back to the domain, right? Where is sine positive in these two like quadrants, quadrant 1 and quadrant 4, right? Is in quadrant 1. So our angle here is equivalent to what? If we start off as like a pi over 3 like derivative, we have to go back to the pi over 3 derivative, which is just pi over 3 because it has to fit in quadrant 1. It's not that bad just knowing the domains and stuff. So I hope this is like making sense. But yeah, so let's move on to 3c now. We have what? We have tan inverse of tan 3 pi over 4. Okay, so 3 pi over 4 falls in what quadrant? This is quadrant 2, right? Because 3 is less than 4, so he doesn't pass pi just yet. He's stuck in quadrant 2. Looking at tan's domain, right? This is quadrant 2. It doesn't really fall in between the 1 and 4 again, right? So we got to do something about that. So let's draw a unit circle again. He's somewhere here, right? So let's draw this guy. Tan 3 pi over 4, right? Oh, right. What do we know about quadrant 2? It's a negative and a cosine, or negative cosine, positive sine, right? So we know that tan is what? It's just sine over cosine. So if we have a positive over a negative, right, what do we get in the end? We get a negative. So what I can do here is revise tan 3 pi over 4 to become just negative tan of pi over 4, right? So this guy just becomes a negative tan pi over 4. So what's the value of tan pi over 4? If I go to sine 1, 2, 3, cosine 3, 2, 1, right? Pi over 4, or oops, pi over 6, pi over 4. So I have 2 over 2. So tan pi over 4 is equal to what? Negative square root 2 over negative square root 2 over 2. Ah, fraction over a fraction, right? What did I say about this, right? This goes here, and this goes here, right? Yeah, let's just do reciprocal. So like that. Reciprocal of this, it just becomes 2 over square root 2, multiply across, and we get what? We get 2 square root 2 over 2 square root 2, because 2 square root, right? And they're both negative, so it becomes positive. So this becomes what? Just 1, because these cancel out to 1, and these cancel out to 1. So we have 1 over 1. 1. So here, our negative tan of pi over 4 becomes just negative 1. I bring down the negative from here, boom, negative 1. So now the question becomes, right, the tan inverse of negative 1, because we converted this into this guy into negative 1. It's a lot easier than like just knowing like any pi over 4, like tan of pi over 4 is just 1. Like it's a lot easier to just know 1 than just do this whole thing, right? But I just did it anyways because, yeah. So the new question now is, what's the inverse? What angle is like tan equal to at negative 1? Going back to his domain, right? His domain is negative pi over 2 to pi over 2. So what do we know about this guy? Where is tan positive and where's tan negative? In quadrant 1, our values are all positive, right? So this has to be positive. Here we have a positive cosine but a negative sine. So this is negative. So what angle gives me 1, but it's negative 1? So, and what did I just say? I said that any like pi over 4 derivative of tan is equal to 1, right? So if I know it's a negative 1, it's some sort of angle that gives me some sort of pi over 4 angle that gives me a negative number. So this is just negative pi over 4, because it has to be pi over 4, like some sort of pi over 4 form, and it has to be negative because I have to be in the negative zone here. I know some of you guys were a little confused with like, since like we know the domain is like quadrant 4 and quadrant 1, right? I know a lot of you guys went like all the way around. We actually go in negatives when we talk about like this quadrant 4 area. So here I just went down. So like we start at 0, and then we just went down a pi over 4. So I know a lot of guys put like what 7 pi over 4 sometimes. Yeah, don't do that. So just pi over 4. I guess I can just knock out d as well. So all right, so 3d gives me the sine and the sine inverse of 0.7. Okay, so I know we just did a lot of like domain stuff, right? But most of these trig functions have a domain of like 0 to 1, I'm pretty sure, or like negative 1 to 1. No, I don't know. Oh my God, I actually don't know. But this one I can just kind of cancel out because it falls in between the range of 1. I know that. So our answer is 0.7, because yeah. The next one, right, is e. So we have the sine and the cosine inverse of 5. This is like a little, it's just like kind of you know it. If you know it, you know it kind of thing. So basically, 5 is bigger than 1. That's out of our range. So this is like D and E. Does not equate because the 5 is just bigger than 1, out of our range. We don't know. And yeah, that's really about it for this section. Just a lot of domain like work. Yeah, that's pretty much it. All right, so coming back, we are doing graphing now. Our favorite, yes, I know. All right, so this is 5a. We have y equals to negative 2 cosine of 2x plus pi over 4. Cool. So let's go ahead and get started. We always break it down into like different categories. So we have our A, right? So A is our amplitude, which means how high or how low it's going. So it's always the absolute value of whatever the coefficient this is. So we have -2 here, so -2 becomes just 2 because absolute value, right? So our amplitude is 2. What's our B? Oh wait, before I do that, let's do y equals to a cosine of bx minus c plus d, right? So this is like our sample or like parent function kind of, if you will. And we just know like where the values go, right? So we have a, b, c, d, so on and so forth, right? So a came from here, right? -2, blah, blah, blah. B is inside the parentheses before the x or the theta. It could be either. So here our b is what? It's 2, right? And our c is what? C is our, do we call it phase shift? I don't think so. But basically it's the opposite of whatever this is. So we have a positive plus, a positive pi over 4. So this becomes a negative pi over 4. And do we have a d or midline? No, right? So what do these mean? A is how high or how low the graph goes. B is essentially like, what's our period? Well, let's do that actually. So period. We have a formula for period, which is 2 pi over b, right? So 2 pi over b, which is 2. So 2 pi over 2 gives us just pi, because these cancel out to 1. Boom, pi. C, phase shift is equal to c over b. So c over b. So we find that c was what? Negative pi over 4. So we have negative pi over 4 over b. And we know b was equal to 2. So we have a fraction over a whole number. So what I like to do is just draw the number to the denominator. So here, this is a multiplication, by the way. So this becomes negative pi over 8. Boom. Phase shift is negative pi over 8. Period is just pi. D is just 0. And so now we've pretty much broken down this graph into like chunks where we can use each chunk for our respective thing, right? So first things first is our parent function, right? What's our parent function? Our parent function is literally just like what? Cosine of x, right? So now we need our 5 key points. As per usual, right? Well, actually no. For normal graphing we do like 3, I think. So yeah. So but for these graphs we need 5. So we need 5 key points that come from the unit circle. So what's the angle that we always start off with when we're dealing with unit circle? It's always going to be 0, right? What's its coordinates? We know that it's what? 1, 0, right? Because the radius is 1 and it stops at 0, blah, blah, blah. Or y equals 0, right? Our next angle is pi over 2. What's its coordinates? We know that's what? 0, 1, right? 0, 1. Our next angle is pi. What's its coordinates? It is -1, 0, because, yeah, math. So next angle, 3 pi over 2, his coordinates is 0, -1, 0, -1. And we go back to 2 pi here, which is the same coordinates as 0, so 1, 0. So the way we do our key points for like sine and cosine graphs, right, is like instead of x, y, now it's angle, like whatever it is. So in this case, it's our cosine, and we know that cosine in these coordinate forms is like basically our x's, right? So cosine is like the first number, or our x's, whatever, right? So how to write this out is, what was the first thing we started off with? It was what? It was 0. 0. And what was our cosine value of 0? It was 1, right? Because it's our x. So 0, 1. Moving on, next angle is pi over 2. Pi over 2, 0. 0. Next angle is pi. Our x value was -1. Moving on, next angle was 3 pi over 2. 3 pi over 2, 0. And our last point was angle 2 pi and 1. So let me draw the what like cosine normally looks like. So imagine this is like our normal grid, right? So we have what? 0, 1. So let's say this is 1, -1, this is 0, and so this is 2 pi. So 0, 1, 0, 1, we have, let's say this is pi in the middle, right? So pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. Boom. Connect the dots, and we have like a little bit of a U-looking thing, right? This is what cosine normally looks like. So moving on to our transformations part of the thing, right? So I'm gonna go ahead and write out our parent functions over here. So we have 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. Okay, so the first transformation I always do is amplitude. It is the most straightforward one because all we're really doing, right? So if we look at the function as a whole, right? Where's this -2 or this 2 coming from? He's outside of the parentheses, right? So if he's outside the parentheses, it's affecting our y's, right? So looking here, what are my y's? It's 1, 0, -1, 0, 1, right? So I'm gonna do here 2y. So this is becomes, so if I know that this -2 affects my y values, right? All I gotta do is just transfer over my old x's or my old angles. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So boom, 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 boom. And now all I gotta do is just multiply this y value by 2. So 1 times 2 gives me 2. 0 times 2 gives me 0. -1 times 2 gives me -2. 0 times 2 gives me 0. And 1 times 2 gives me 2. So boom, we have our amplitude plugged into the new values, and so we're done with the amplitude. Well, actually now, hold up. Yeah, so let's do reflection now. I think it's better off I do that way. So if it's -2, this 1 becomes -2, 0 becomes 0, this -1 becomes +2, +2, 0, and then this becomes -2. That is, yeah, that makes sense. That makes sense. All right, so let's move on to the next part, right? It's now, so we did the first part here, so let's move into the inside, right? This b value basically means that this period is being this period is basically being, it's compressed. So our normal period is 2 pi, right? So imagine 2 pi, and now we're moving into pi. So this whole graph is being compressed into a factor of 2 basically. So I'm gonna do x over whatever our b value is here, which is 2. So, all right, so if it's inside the parentheses, this is affecting our x values. So here I put x over 2 to signify that. So what we do is we just kind of move our y values over. So we have -2 here. We have 0, 2, 0, and -2. Wow, this is starting to get really ugly already. Wow. Damn, that's bad. Okay, so let's go ahead and start doing this, right? So we have 0 divided by 2, 0. Pi over 2 divided by 2, right? Basically like this, just multiplied to the bottom. So this is pi over 4. Pi divided by 2 gives me pi over 2. 3 pi over 2 divided by 2 gives me 3 pi over 4. 2 pi becomes over 2, or we just put it as pi. So let's revert that to pi. It's just easier to understand. Cool. So now we did the inside. Now we have to do our plus pi over 4, or our phase shift. So basically our phase shift is always going to be our first point. So if I found out that phase shift was -pi over 8, right? Let's put this as phase shift here. Phase shift. So if I know that this is my new first x, right? I kind of have to adjust the graph to fit this, right? So if this moved, so we went from 0 to -pi over 8. So basically that means the whole graph shifted -pi over 8. So -pi over 8. And since -pi over 8 is my x, or my horizontal shift, right? All I gotta do is just kind of subtract negative pi over 8 from these. Or another way we can do it, right, is to find our period, right? So our period was pi. If we do divided by 4, we get pi over 4. So this is like my new like interval, if you will. So like our first point was negative pi over 8. So I have to add this to this guy to get the next 4 points. So like we would take this plus pi over 4, whatever point we get next plus pi over 4, and then like that point plus pi over 4, and then we complete the rest of the graph. So yeah, this actually isn't negative pi over 8. I'm bugging. This is actually plus pi over 4. So let's go ahead and do this. So negative pi over 8 plus pi over 4. So as we can see, our denominator here is different, right? We have 8 and we have 4. So how do we convert this 4 into terms of 8, right? So just multiply top and bottom. So times 2, like, because that's how they're related, right? So this becomes negative pi over 8 plus 2 pi over 8. So in other words, right, we have what? Negative 1 plus 2, which gives me just positive 1, right? So my next point, oh wait, I didn't finish this. So our x's changed, but our y's didn't. So this becomes negative pi over 8, comma, negative 2. Our next point I found was negative pi. So our first point plus our period over 4 factor. So this, what is this, period over 4. So this, our next point, our next x is pi over 8. Pi over 8, comma, 0 from our other point. So this is another transformation. Okay, so now we take pi over 8 plus pi over 4. Or if you want to keep it simple, right, instead of writing pi over 4, we just kind of think of him as 2 pi over 8. So we're adding just plus 2 pi over 8 every time, just so like we don't have to do this whole conversion thing all over again. So pi over 8 plus 2 pi over 8 gives me 3 pi over 8. 3 pi over 8, comma, what? Comma, 2. Okay, moving on. 3 pi over 8 plus 2 pi over 8 gives me 5 pi over 8, comma, 0. And then 5 pi over 8 plus 2 pi over 8 gives me 7 pi over 8, comma, negative 2. Boom. And so now we kind of see it fits all in a period because we have like pretty much negative 1 to like, we're missing like a negative 1 here, if that makes any sense. So I think they want us to graph. Key points, so final key points is this. I went from the original basic function, like points, to now these are our key points that fit this function. And then graph one cycle of the basic with dashed lines, graph the final, okay. I guess I already did the basic function. Okay, so let's go ahead and draw another graph out. Okay, so my highest point here is negative 2 and 2. So let's label this as 2. This as negative 2. And this is like pi. Okay, so let's say this is negative pi, and this is positive pi. Okay, and so let's go ahead and start graphing, right? So our first point here was negative pi over 8 and negative 2. So let's say this was negative pi over 8 and negative 2. Boom. Pi over 8 comma 0. So 0, pi over 8, and 0. We have 3 pi over 8 comma negative 2, or positive 2. Oops. So let's say 1, 2, 3, and then 2. 5 pi over 8, so we had what? 1, right? Hold up. 0, 1, 2, 3, 4, 5. Right? And then 7. So 5, 6, 7, let's say. Oops, I didn't mean to do that. Somewhere down here. Is that on point? Yeah, something like that. So connect the dots. And we are looking something like that. So this is one period of our final equation. This is our basic function, and this is our final. So yeah, cool. All right, so, but yet another graph question. I know, it's our favorite. Oh my God, graphing, right? So we did cosine in the previous one, now let's do a sine one. So let's go ahead and break it down. So our A, oh, let me write it out again, hold up. Our model, what is it? A sine bx minus c plus d. Okay, so let's start, right? So our a is what? Easiest one is just 2, or absolute value of 2, 2. Our b is equal to 4. Our c is equal to what? It is like opposite of this, so this is positive pi. And our d is, but yet again, y equals 0, because there's nothing there. So let's find period. Period is equal to 2 pi over b, which is what? 2 pi over 4 over 4, or in other words, this gets cut out to 1, this gets cut down to 2. So our period is pi over 2. So we went from 2 pi, which is pretty like sizable, to pi over 2. Pretty sizable compression there. And then we got phase shift, right? So phase shift. Another way you can do phase shift is pretty much set everything in the parentheses equal to 0. So let's do that. So we got 4x minus pi equal to 0. So 4x, move the pi over, 2 pi, and then x is equal to pi over 4. Phase shift, boom, just like that. And that pretty much covers it. So let's go ahead and do our parent function of sine then. Okay, so I think I did it in this corner last time. So again, draw our unit circle. We have first angle. So wait, what is it? Parent function is y equals to sine x, right? So first angle is what? It's always 0. Coordinates are 1, 0. Next one is pi over 2. What is this? 0, 1. Then we got pi, which is negative 1, 0. 3 pi over 2, 0, negative 1. Back to 2 pi, which is 1, 0. Cool. So again, right, what did I say again about when we graph, right? It's x and y format, but instead of x and y, now we have our angle, comma, whatever like the result of our function is. So here we have parent function y equals sine x, right? So first angle was 0. And so sine, what did I say about sine? It's our x's or our y's. It's our y's, right? Yes, yes. So we have angle 0, and our y value is 0. So our first coordinate here is 0, 0. Next angle we got is pi over 2, 1. Our next angle is pi, and our y value is 0. 3 pi over 2, y value of negative 1, or sine value of negative 1. And then we have 2 pi of 0. Boom. So this is our 5 key points of the basic function. There we go. Yes. So we got the 5. So let's go ahead and transfer it down here. And then we'll start. So 0, 0, pi over 2, 1. We have pi, 0. 3 pi over 2, negative 1. And 2 pi, 0. So I'm going to go ahead and draw our basic function. So let's say this is negative 1, 1, this is 0, 2 pi, and negative 2 pi. So we have 0, 0 starting off, 0, 0. Let's say this is pi, this is negative pi. So we have negative pi, or oh my god, pi over 2, 1, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Connect the dots, and we can have like our sideways S looking thing, right? So back over here, again, so they teach another format. I don't know what it's called, but I do like all the transformations like step by step. I think they want like all the transformations all in one go. I don't recommend it because it's really confusing, especially with like really ugly like setups. So I recommend you go step by step, like how I'm doing here. So I go like amplitude first, and then I do like B, and then I do like phase shift, period, all this stuff, like one by one. I know it's a lot more like writing and work, but it's just a lot more like more thorough, and you can see like what you're doing. So in the case that you do mess up, you know exactly where you messed up, and you'll go back to there or whatever, right? So again, I start with amplitude. So amplitude is what? It's on the outside of the parentheses, right? Outside. So we know this is affecting our y values. So here I'm going to go ahead and put 2y. So I'm going to keep ahead. I'm I'm gonna write out all my x's. Boom, boom, boom. Boom, boom, boom. Let me get that. Boom, boom, boom. Right. So 2y. So 0 times 2 gives me 0. 1 times 2 gives me 2. 0 times 2 gives me 0. Negative 1 times 2 gives me negative 2. And 0 times 2 gives me 0 yet again. There we go. So moving on to the next guy, we have what? What's on the inside of the parentheses here? We have a 4x, right? So most important thing is our b, which is our 4, right? So now I'm going to do, so whatever's inside the parentheses is affecting what values again? It's our x values. So I'm going to put x over b, or x over 4 in this case. So now what I want to do is write out all of our parentheses again. 1, 2, 3, 4, 5, comma, 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 comma. So I'm going to keep all of my old y values, negative 2 and 0. Okay, so now x over 4. So basically I'm taking all this and divided by 4, right? So pretty self-explanatory. 0 divided by 4, 0. Pi over 2 divided by 4 gives me pi over 8. Pi divided by 4 gives me pi over 4. 3 pi over 2 divided by 4, 3 pi over 8. Then we have 2 pi divided by 4, which is just basically pi over 2. Okay, moving on. Now it's phase shift time. So we found our phase shift to be pi over 4. So this guy, or our 0 becomes pi over 4. Hold up. Phase shift, arrow, pi over 4, comma, 0. Cool. So now let's do the whole period over 4 thing, right? I think I explained it in the previous one, but like phase shift is always our first coordinate, and then the remaining 4 are found from the period over 4 method. Period over 4, which is equal to, what's a period here? It was pi over 2. Pi over 2 divided by 4. So it's supposed to be equals. So this gives me times, so this is pi over 8. So now using this pi over 8, right, I can just add him to our phase shift, and we find x2, x3, x4, x5. So let's go ahead and do that now. So we have, I'll do it here, I guess, period over 4 plus pi over 8. No, pi over 4 plus pi over 8. I think I said period. I don't know. So to get this denominator to match, right, it's 4 and 8. So this means 4 has to be multiplied twice to get to 8, right? So top and bottom are multiplied by 2. So we get 2 pi over 8 plus pi over 8, right? So combine these two, we have 2 plus 1, 3, right? So our new point is 3 pi over 8, comma, what? Comma, 2. Then we have, oh, right, next guy. So 3 pi over 8 plus 2 pi over 8. Wait, no, we're adding this, my bad. So 3 pi over 8 plus pi over 8 gives me 4 pi over 8. We could reduce this, but let's just keep it over 8 just for simpler like reasons, because this is a really small like graph. So it's easier to just keep like track by keeping like all in the same order. This guy could probably change to 2 pi over 8 just to keep things simpler. But yeah, you get the gist. So we have 0, 2, this is 0. So 4 pi over 8 plus pi over 8 gives me 5 pi over 8, comma, negative 2. And the next guy is 6 pi over 8, comma, 0, because 5 pi over 8 plus pi over 8 gives me 6 pi over 8. Cool. So now these are my final key points of this graph. So let's go ahead and draw out our good old graph. So noticing the points, we have 0 and 2 and negative 2. So let's say this is positive 2, this is negative 2, 0. Let's do pi. Pi down here, negative pi. And yep, let's start graphing, right? So first point is pi over 4, comma 0. So let's say, I'd say this is probably like the halfway point. So what is this? Pi over 4, comma 0. Then we have 3 pi over 8, comma 2. So let's say it's like here, comma 2. 4 pi over 8, comma 0. It's like about halfway point. Boom. Sounds about right. 5 pi over 8, negative 2. Something like that. And then it should be 6 pi over 8. So seems about here. Yeah. And then just connect the dots. Boom, boom, boom. And we got our good old graph. So our basic function looked a more, well, I know it's like not the same scaling, but like this is more more of a big S, and this is like a very small s. And yep, that's about it for this one. Cool. All right, and so for number 7, we have find the exact value. So this is going to be 7b. So, so we have tan inverse of positive 1. Okay, so remember earlier I said like anytime we have like a tan of like 1 or a tan inverse of 1, it's always going to be some sort of like derivative of like pi over 4, right? So let's draw out the unit circle once again, right? So tan's domain falls in between pi over 2 and negative pi over 2. So basically what this is saying is, where is tan positive 1, right? So positive 1, so we're going in quadrant 1 here, quadrant 1, right? So knowing what we know about like 1 and tan inverse, right? Basically we're saying where in quadrant 1 is tan positive 1? Okay, well, what kind of derivative do we have of pi over 4 in quadrant 1? It's just pi over 4, right? Boom, that's the answer. Moving on, let's do 7f. I have cosine inverse of negative square root 3 over 2. Okay, so let's draw a unit circle once again. Boom, boom, boom. Cosine's domain is 0 to pi. So here, where is cosine equal to, or what angle of cosine is equal to negative square root 3 over 2? Okay, so this is positive cosine, and this is negative cosine, right? So what angle is cosine? Yeah, I just said this. So let's do cosine 3, 2, 1 and sine 1, 2, 3. So we have pi over 6, pi over 4, and pi over 3. Looking at cosine, right, where is the 3? The very first one, right? So it's some sort of derivative of pi over 6. So if we know he's negative, right, he has to pass the pi over 2 like landmark. So pi over 6 in quadrant 1 is just pi over 6, right? 2 pi over 6, 3 pi over 6, 4 pi over 6 is like it's pi over 3. So the other pi over 6 derivative is in quadrant 2 is 5 pi over 6. So yeah, since pi over 6 is like the smallest like slice of pie, I like to think of it, right? He kind of falls in between the other angles as well. So like I was saying earlier, it's like 2 pi over 6 is just reduced to like 2, and this is 1. Oops. So this is pi over 3. So 2 pi over 6 is the same thing as pi over 3. So if you get what I'm saying. So 5 pi over 6 is the only like the prime angle in that quadrant 2. All right, so now begins the fun part. It's the big ol' board problems. These are the bastard questions of this section. I mean, I can't guarantee you'll see something like this, but it's like 70-30. Sometimes they do it, sometimes they don't. But let's do it anyways, right? So we have here that a building 160 feet tall casts a 60-foot shadow. So triangle, right? So these questions are always going to be triangle questions. It's like assumed like it's a right angle, right? Because it's like a straight object and some sort of like straight object as like adjacent or something. Or they'll say it like you just kind of read. So imagine this is a building. Let's do a little square, right? So this is 160 feet tall, 160 feet, and it casts a 60-foot long shadow. Imagine that's a shadow. I don't feel like doing that whole thing. So 60 feet long shadow. A person stands at the end of the shadow and looks up to the building. What is the angle of the person's eyes to the top of the building? Assume the person's eyes are 5 feet above ground level. Oh my God, okay. Oh boy. Okay, so we have a little person here. So let's draw little Timmy, right? What is the angle of the person's eyes to the top of the building? So this is like, we're drawing like another triangle here. Does that make sense? Yeah, so like imagine like little Timmy was like up here instead, right? Like there's like 2 triangles that I'm trying to say. It's like an angle here and angle here kind of thing. Wait, no, that visual doesn't make sense because like it's supposed to be 60 feet long. Anyways, we'll get to it. So draw a visual first. Okay. What is the angle of the person's eyes? Okay, so let's find the big angle first, and then we'll find the smaller angle next. So if we know that the building is 160 feet tall, or they gave us 160 for like the building, right, and 60 feet for the adjacent, what do we have? We have what? In regards to this angle, we have opposite, and adjacent. If we remember our good old friend, right? SOHCAHTOA. SOHCAHTOA. Right? What's opposite or adjacent? It's our good old friend tan. But let's just say we're taking 5 feet off of this, so this becomes 155 instead, in regards to like little Timmy, right? So we have tan theta is equal to 155 over 60. We take the inverse of the tan, so we just swap the theta and the whole fraction, right? So our theta is left isolated equal to tan inverse of 155 over 60. They simplified everything in terms of 5. So simplify by 5. So yeah, questions like these, it's like, a lot of it's just the wording. Like, you saw me, I kind of struggle with this a little bit. Like, I don't know what the hell they want sometimes. So it is what it is, but yeah, just kind of be prepared to draw like an image, just given context clues of what they give you. Like, the most important part here is they gave us like the height, which in relation to the angle they gave us, or they want us to find, is the opposite, and the length of the shadow, which is the adjacent, which is tan, blah, 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 right? We got this. Yeah, that's pretty much it for this one. All right, so this is number 10, yet another word problem, right? We have a news helicopter is 1,500 feet directly above the finish line of a marathon, 2 runners to the right of the helicopter, blah, 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 blah. Okay, so most important thing we got here, we got a height. We got 1,500 feet. Let's say this is like a, yeah, let's say that's a helicopter. Ooh, right. So we have helicopter above the finish line. So let's try like a little checkered flag, I guess, to signify. Yeah, I don't feel like filling that out. Okay, cool. 2 runners to the right of the helicopter. Sight the helicopter with angles of elevation of 35 degrees and 67. Okay, so I'm assuming that this is like 2 angles like this, or 2 triangles. I think this would be 67. I think the bigger one goes on the outside. No, wait, hold up. So if I were to stand here and look up like this, bigger angle. Okay, so no, hold up. Other way around. So big angle goes on the inside because he has to look up like further up, is my whole logic here. So this is 67% or 67 degrees. Jesus, okay. 35 degrees, cool. And then we've got a little right angle here. How far apart are the runners? Okay, cool. So let's call, okay, so let's say, So let's say that this whole length here is, let's say x, right? And then let's call this bigger chunk, let's say y. And then this other chunk here, let's call him z. Okay, so, now what am I reading? How far apart are the runners? Okay, so basically what we're looking for is z here. So let's draw little Jimmy, and then we got little Justin over here. Okay, so draw a visual first, leave it calculated and ready form. Okay, cool. So we are given what? We are given a height, and we are given angles. So what are we missing here for y and z? We're missing what? The adjacents, right? So let's go ahead and, let's write out SOHCAHTOA, right? Good old friend SOHCAHTOA. SOHCAHTOA. So we were given so in relation to this angle, right? So we have the opposite and we have our adjacents. So good old friend tan once again. So let's do a bigger triangle first, right? Because we can find x and we find like the other one. So let's do big angle first. So our big angle here is connected, or our angle here is 35, what I'm trying to say, of the bigger triangle. So we have tan of 35 equal to what? Adjacent, or opposite, so 1,500 or over our adjacent. So I said like the biggest side is equal to x. Let's call them x. So how do we solve for x here? How do we do that? So if I were to multiply this over here, right, I have x tan 35 equal to 1,500. How do I isolate x? I have to just divide tan 35, right? So I'm left with x equal to 1,500 over tan of 35. So now that I have this, right, so I have the whole side down here, how do I find y now, right? So I said that the bigger triangle is connected to 35 and the smaller triangle is connected to 67 because the runner has to like look up further up to, so does that make sense? So like, okay, so imagine like I'm looking at the corner of the room, right? So if I were to stand here and I look up, it's like a wider angle or a bigger angle because I have to look up further. But if I were to step back a little bit, I can see that corner of the room like in my like already vision like this. So like the angle isn't as big. Yeah, that makes sense. I hope. So yeah, so let's go ahead and find this smaller triangle, the adjacent of the smaller angle. So yet again, we use tan. So tan of 67 equal to what? Opposite, which is 1500, over our adjacent, which is y in this case. Y. So how do we isolate y? So let's do the same thing. So multiply y over to this guy. So y tan of 67 equal to 1500. Y is equal to 1500 divided by tan of 67. So now that we have x and y, right, what I can do now is just take x and subtract y from x. And whatever I'm left with here is equal to y, or to z. Jesus, okay. So let's go and do that. So let's do x minus y, right? So x is just 1500 over tan of 35 minus 1500 of tan 67. So our z should be equal to this, and that z is the distance between the two runners that they're asking for. Okay, yeah. So so they did this, then they also did a cotangent version, which is like, there's no fractions, they like just kind of like converted like tan into 1 over cotangent, but don't do that. Just leave the, like this in the way it, like as it is, because this is a lot easier. If you convert, things might get a little ugly. So yeah, if you follow the visual to here, they have the same thing as me. They just didn't include like the y or x thing. Yeah, so this is it. All right, so this is starting chapter 9. So now we have all the trig identity stuff. So remember I was saying earlier, like the sine squared, all that stuff, right? Now we're getting to like the properties or whatever the hell this is called. So for number 1 here, we have complete the identity, cosecant of x times sine x plus cosine of x. Yeah. So what it's doing here is basically we're asked to distribute cosecant to sine and cosine here. So what you could do here is like break down cosecant in terms of like sine, like any trig function that's not sine and cosine. You can just break that down in terms of sine and cosine, just for like visibility, and I guess it's like easier to like process that way. So here I'm gonna do that. So cosecant is what? It's the reciprocal of our good old friend sine, right? So if I know that cosecant is 1 over sine x, right? And I want to distribute to sine of x plus cosecant of x, or cosine of x, my bad. Here we go. So let's go ahead and distribute this, right? So if we distribute sine to here, we get what? We get sine x over sine x, or equal to 1, right? Okay, then here, if we multiply cosecant to 1, we get, why do I keep saying cosecant? It's cosine. Oh my god. So it's cosine over sine, right? And what does that look familiar to? Cosine over sine is our good old friend cotangent, right? Hopefully we still know our things. I guess I'll write it out here, right? So we have, let's do cotangent. Oops. So cotangent x is just 1 over tan x. Secant x is just 1 over cosine x. And cosecant x is just 1 over sine x. So we'll be using these properties a lot in this these sets of questions. So for number 1, this should be answer choice A. Answer choice A. Let's do question number 2 now. We have complete the identity, sine of x over cosine of x plus cosine of x over sine of x. Okay, so we have a fraction plus a fraction. So if we look at the denominators, what do we have? We have cosine and we have sine, right? Two completely different denominators. So how do we get these to like merge into one like problem, right? So on this cosine side, I can multiply top and bottom by the denominator of this guy. So I'm going to multiply sine x to the top and bottom of this guy. And on this side, I can multiply the top and bottom by terms of cosine. So let's do exactly that. So we have sine x over cosine x and sine x plus, yeah, this is right. So this is cosine x. What am I doing? What did I do over? It's this, okay. And then this is cosine of x again over sine x times cosine x. Cool. So now let's work it out, right? So sine x times sine x gives me, surely we know this one, right? Sine squared x, right? Sine times sine gives me sine squared, right? So sine squared x over cosine times sine x gives me, well, ugly, but cosine x sine x. I like to put the dot in between just to know like it's combined, but it's like two separate things, right? So, and then over here, cosine times cosine gives me cosine squared x, right? Over, again, we have cosine and sine multiplied. So I would keep it simple and just like, well, like, so this one's cosine and sine, this is like sine and cosine. I would just flip them, right, to keep them in the same order. But if you understand like they're the same thing, even though they're flipping around, then cool. So here, right, now what do we have? We have sine x over sine squared x over cosine x sine x plus cosine squared x over cosine x got sine x. Basically, we have the same denominator. So let's write this out. Sine squared x plus cosine squared x all over cosine x times sine x. So what does this guy look familiar to, right? Remember earlier I was talking about this guy, right? So we have sine squared x plus cosine squared x equal to 1. This is Trig Identities, I want to say. Trig Identities. Or Pythagorean identities? I don't know, something identities. Basically, right, sine squared x plus cosine squared x equal to 1. Boom, right? Right? So all this is really saying is now it's just 1 over cosine x times sine x. But back to this topic, right? We're going to do this a lot, like switching from like these squared trig functions to like 1 something, right? We're playing around with that a lot. So it's important to know this one. This is the simplest one, right? It's just sine plus cosine squared x equal to 1. So there's like 2 other ones, right? We can derive from this. So if I were to go ahead and divide this all by sine, right? Every term by sine squared x, right? What do I have? Sine squared x divided by sine squared x gives me 1. Cosine over sine gives me good old friend tangent or cotangent, right? 1 over sine is cosecant, right? Now, if I were to go ahead and instead of dividing by sine, right? And now we're divide by cosine instead. Cosine squared x, cosine squared x, right? What do I get? I get sine over cosine. That's good old friend tangent. Tangent squared x plus cosine over cosine gives me 1 equal to what? 1 over cosine is good old friend secant. So let's go ahead and erase this. And just like that, we have our 3 trig identities. So now, granted, you won't see them so simple like this every time, like sine squared plus cosine squared, right? Sometimes you'll see like, I don't know, cosecant minus 1, right? It's like, oh, what is that equal to? Well, it's literally just cotangent, right? But we're moving the terms around. Sometimes we got to play around with the terms, make them the way like they're processed, so you know which one's which. So I think we'll see that more as we go on here, but just keep that in mind. Like sometimes the variables will move; they're not always in this static position like this. And yeah. Okay, and so for number 3, we have complete the identity: tan x times big parentheses cotangent x minus cosine x and big parentheses. So let's go ahead and write these out in terms of sine and cosine, just for visual clarity, right? So tan is equal to the same thing as sine x over cosine x, right? Times, big parentheses, what's cotangent again in terms of sine and cosine? It's cosine x over sine x minus cosine x, and big parentheses. So let's go ahead and distribute, right? So if I were to distribute these two, so we have sine x cosine x over sine x times cosine x. I'm just going to keep them the way they are because it's, or like in this format, like sine first, like, you know, they're the same thing basically, right? Minus this whole thing. So let's do sine x over cosine x minus, what in the world am I doing? 1 second. Minus cosine x. So here, right, since they're the same on top and bottom, I just kind of cancel out everything top and bottom and it just becomes 1, right? Minus this whole thing. So what do we notice here? We have what? Sine over cosine x and being multiplied by cosine x. So if the top is like canceling out the bottom, right? So like here, this is reduced to 1, blah, 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 right? So we have 1 minus sine x. Boom. Just that simple, right? So let's go ahead and do number 4. Number 4 gives us complete identity. Sine squared x plus sine squared x times cotangent squared x. All one term. Okay, and what is it equal to? So let's go ahead and look at the problem. So we have sine squared x, cotangent x. So let's go ahead and write him out in terms of good old sine and cosine, right? Sine squared x and multiplied by, big parentheses, cosine squared x over sine squared x, big parentheses. So what do we notice, right? We have sine squared x multiplied by a denominator of sine squared x. So let's go ahead and cross them out. Rewrite this again as sine squared x plus, pretty much these cancel out, so we're just left with cosine squared x. Oh, look at that, right? Sine squared x plus cosine x. Boom, equal to 1. Okay, and so for number 5, we have complete the identity. So number 5, we have cotangent x times tan of x. So break them down to sine and cosine like always. So this becomes cosine x over sine x times sine x over cosine x. And what do we notice, right? We notice what? It's cosine x on the bottom, or on the top, cosine x on the bottom, sine x on the bottom, sine x on top. So, right, we just cancel out, and we're left with what? With just what? 1 times 1 equal to 1, right? So for here, this is answer choice C. And then let's do number 6 as well while we're at it. So number 6 is verify, okay, maybe I shouldn't run it up so high. Sine x plus cosine x, big parentheses squared, okay, over 1 plus 2 sine x times cosine x. Yes, equal to 1. Okay, so verify that this big old thing is equal to 1. So let's start with the top, right? We have what? Sine x plus cosine x squared. So let's do that. Sine x plus cosine x okay, all over 1 plus 2 sine x times cosine x. Yeah, okay. So this top, right? We're not quite done yet because this is like factored form. So what this really is just foiling, right? So, right? So first, outer, inner, and last, right? So first, right, it's sine times sine x. So sine squared x, right? Outer, no wait, right? Foil, first, outer, inner, yeah. So outer is sine x times cosine x. So we have sine x times cosine x Inner is cosine x, same thing. I don't want to write it out the whole thing again, so let's put a 2 here because it's the same thing, right? And the outer is, wait, what? No, last is cosine x times cosine x, so cosine squared x. So we're left with this on top, all over 1 plus 2 sine x cosine x. Okay, what do we notice, right? What do we notice? We have sine squared x, cosine squared x. If I were to like move them around, right, I'm left with the same thing, right? Sine squared x plus cosine squared x, right? So let's rewrite this as just 1 plus 2 sine x cosine x, right? And what's on the bottom? We have 1 plus 2 sine x cosine x. Well, would you look at that, right? We have the same thing on top and bottom, yet again, right? So what I can just do is cross them both out, and they're equal to 1. So 1 over 1, and end result is 1. Let's look at the verification they gave us in the beginning, right? It was like this whole big thing equal to 1, right? And that's about it. All right, so continuing on, we have number 7. We have verify that sine squared x plus tan squared x plus cosine squared x is equal to secant squared x. Okay, cool. So sine plus cosine squared x, right? Right. Again, you see a trend here, right? So we combine those two to become 1. So 1 plus tan squared x, right, equals to what? So this is like another thing, right? So what do we see? Tan squared x and 1, right? Tan squared x, 1. So again, like I said earlier, right, they're not always going to be like statically like tan squared x plus 1 like this, right? But like they could be flipped, they could be like other properties, or they could be like moved around like the left and right. So here it just equals to secant x. Like this is just a lot of like property knowledge, I guess, like knowing the identities. So that's it. That's as simple as that, right? As simple as it gets. Okay, so we're doing number 9 now. So it says find the exact value of sine of 165. So I'm gonna go ahead and segment this into like a little bit of a lecture here, because things get a little wild now, right? So we're finished with trig identities. So let me go ahead and erase this, and I'll work with the space over here in regards to the formula here. So, okay, so this question, right, sine 165, we don't really know what the exact value is. Like, it's not like a special angle for us, right? So what this really is, right, so let's go ahead and draw this out. Where is sine of, or where is 165, right? So we have 0, 90, and then like 180, right? So we know 165 is somewhere around here. So let's go ahead and draw a little arrow, right? So basically, right, this is a combination of like 2 angles. This is an addition problem of like sine. So 165 is essentially, so what are the angles we have? We have like what, 30, 45, and 60, right? How do we get to 165 in terms of like these numbers, right? So what I could do here is just sine of 120, right? So this guy here, like 2 pi over 3, 120, plus sine of 45. And this adds up to 165, right? As you can see, 120 plus 45, 165, right? So this is like our setup for our angle formulas here. So this is addition and subtraction of angles, I guess, right? So addition / subtraction of angles. So there's a couple formulas here, right? More formulas, yes, I know, right? So let's go with the first one. We have sine of alpha plus beta is equal to sine of alpha cosine beta plus sine of beta cosine of alpha. So basically what this means is that 2 different angles, right? So similar to this. So 120 and 45, right? So if I replace 120 and 45 here, so the A's match up to like wherever I need to do. So like sine 120 cosine of 45 plus sine of 45 times cosine of 120. It's stuff like that, right? But we'll get back to that. Let me do the rest of the formulas here and kind of like go through it. So this is addition, right? So now what sine's like subtraction form, right, is it's the same format here, right? The most important thing out of this, like the difference between like the addition and subtraction of this one is here. So here we did plus, and this is plus. This is minus now. Sine beta cosine of alpha. Right, so now things get a little wonky. We move on to cosine. So it's only sine and cosine that do these like formulas, right? So this is cosine of a plus alpha, or no, alpha plus beta, sorry. This is now cosine alpha times cosine of beta minus sine alpha sine beta. You see the difference now, right, between like sine and cosine? So here we had like sine alpha, cosine beta, like alternating like a little bit, right? But they keep the same signs in the middle here, and then they finish off the alterations, sine beta, cosine alpha, blah, 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 right? They keep the same signs, this is plus, plus, minus, minus. This guy is going crazy, right? So we have all the cosines on one side, alpha and beta, but now this plus, like the angle plus, right, is now minus. I hope you're understanding this somewhat, right? And then the last one is alpha minus beta. So this is, again, cosines on all on one side. So cosine alpha times cosine beta plus sine alpha and sine beta. And that's pretty much it in regards to the formulas, but the way we use it is a little more different now. So let's go back to this question, right? So we had what? Sine of 120 plus 45. So we have a sine and a plus. So let's go ahead to his formula. We have sine and plus, right? So sine alpha, cosine beta. So here, this is equal to sine of alpha, so the first one, sine of 120 degrees, times the cosine of the second one, cosine of 45 degrees, right? Plus we keep the sine. So this is now sine of the b, so sine 45 degrees, times the cosine of the first one, so 120 degrees, boom. So let's work it out, right? So sine of 120, where is 120? It's in quadrant 2, right? What's the sine values in quadrant 2? They are positive. So this is the same thing as 2 pi over 3, right? So the sine of 2 pi over 3 is just square root of 3 over 2, right? Oh my God, hold up, whoa. Sine, 1 to 3, cosine, 3, 2, 1. I said this was 2 pi over 3, so yes, square root of 3 over 2, positive, times the cosine of 45, which is radical 2 over 2, plus sine of 45 is also radical 2 over 2, times what? Cosine of 120. Where is cosine of 120? 120, quadrant 2. What's the value of the cosines? Cosines are negative, right? And what's the pi over 3, right? So cosine pi over 6, pi over 4, pi over 3. So it's a negative 1/2. Negative 1/2. Boom. So let's go ahead and multiply this out, right? So radicals, like if it's a radical times a radical, we multiply the inside, but keep the radical, right? If they're different, at least. So we have radical 3 times radical 2. We're left with radical 6, and we're just going to multiply this across and keep it as 4. So 2 times 2, 4, right? So here we have what? Radical 2 times negative 1. So we have negative square root 2, right? Multiply across here. 2 times 2 gives us 4. So now, what are we left with? We are radical 6 plus and a minus. We are left with a minus. Square root 2, same denominator, so we are left with this. Square root 6, radical 6 minus radical 2 over 4. Okay, so pivoting from that, right, we're still using the addition formulas here, but now it's a different kind of like format. So we're given, suppose sine alpha is equal to 4 to 5. So, okay, so sine alpha is equal to 4 to 5, and it's in quadrant 1. So let's go ahead and draw our little triangle, right? Let's say this is alpha, I guess. So opposite over adjacent. Oh wait, let me write that out. SOHCAHTOA. So we have opposite here 4, and our hypotenuse is 5. Wait, did I say adjacent? Sorry. Right angle. Okay. And then we're given that cosine is, oh, this is question 13, my bad. 13. And we're given that cosine of beta is in quadrant 4. So like this. Draw a right angle. This is beta. And we're given that is equal to 5 over 13. And then find the exact value of, and they want what? Sine of alpha plus beta. And then we are given cosine of alpha plus beta. Okay, cool. So the most important part is knowing where the triangles are, and pretty much that's really it, and knowing the formulas, right? So we have our good old friend Pythagorean theorem, right? A squared plus b squared equals c squared. So let's say this is a. So we have a squared plus 4 squared from here equals to 5 squared. So this is a squared plus 16 equals 25. What is that, 9? Yes, that's 9. So a squared is equal to 9. A is equal to plus or minus square root of 3. Oh, wait, no, oops, just 3. But the most important part here is knowing where the triangle is. We were told that's quadrant 1, right? Well, what do we know about quadrant 1? Positive x's, positive y's, right? So here, this is my x, right, is a positive 3 because it's in quadrant 1, because we have to know that, right? So we just erase that, and it's equal to positive 3. Let's find the opposite here in quadrant 4. Let's call him b. So b squared equals c squared. Let's take 5 squared from here plus b squared equal to 13 squared. 25 plus b squared equals to 169. B squared is equal to 144. So this is square root, or plus or minus 12. Square root both sides, so what's 12? Yes. Okay, so quadrant 4. What do we know about quadrant 4? We have positive x values, right, because it's over here, but we have negative y values. And this, right, if I know this is my x, this has to be my y. And I know that, I just said what? This is a negative y value, right? So this, I just kind of erased the positive here. So this is negative 12. So now we continue, since we know every aspect of the triangle, right? So sine alpha plus beta is equal to what? If we look here, it's sine of alpha cosine beta plus, right? Got to match the plus. Plus sine beta cosine of alpha. So this is alpha, this is beta, right? So what's the sine of alpha? We have 4 over 5, right? 4 over 5. This might be a little too small. Let me write it over here, actually. So I said this was 4 over 5. So now we're missing cosine of beta. So cosine of beta is what? 5 over 13. 5 over 13 plus what? Sine beta is opposite over adjacent, so negative 12 over 13. Negative 12 over 13. And then cosine of alpha was 3 over 5. 3 over 5, let's go ahead and multiply this, right? So multiply across, we get what? 4 times 5, 20. 13 times 5 is 65. And then here we have a negative, so let's do a parentheses. 12 times 3 is 36 over 65. So now what? We have 20 minus 36. So this gives us a result of negative 16 over 65. Now let's do the second part. We have cosine, right? So we have cosine alpha plus beta. So looking here, we have our formula. So we have cosine of alpha, cosine of beta, minus, because they alternate, alternate. Sine of alpha, or sine of alpha and sine beta here. Let's go ahead and look at the triangles, right? So cosine of alpha was 3 over 5. 3 over 5 times cosine of beta, which was 5 over 13. 5 over 13 minus sine of alpha, which was 4 over 5. 4 over 5, and sine of beta, which was negative 12 over 13. Okay, so let's go ahead and multiply across yet again. So this is 15 over 65 minus, a negative again here. So we have 4 times 12, which is 28. 28 over 65. So here we have what? 15 minus minus, change. So this becomes a plus 15 plus 28. So this is 43 over 65. Let me go ahead and double check my answers here to make sure I'm not wrong. And whoa, I did this something wrong. Something wrong happened here. Whoa. Oh, that's 12. Oh, whoa, hold up. So 12 times 4 should have given me 48. Sorry. This is 48. So 63, 65. And there we go. Okay, so now we move on to the double angle formulas. Definitely not anyone's favorite, but let's go ahead and do them anyways. So, let's write out double angle formulas. Double angle formulas. Okay, so I have written here all of them, but the main one I want you guys to know is the sine and the cosine one. So this is sine of 2a equal to 2 sine a times cosine a. And then here I have the cosine one. So cosine has has 3 different ones actually. I recommend just learning one. I recommend the cosine a minus sine squared a. So yeah, tan I want to say we don't really use, so I'm gonna ignore him for now and move on, right? So this is question number 15. They gave me a figure, so go to a little triangle, right angle here, and we're given theta's right here. Theta, we have a 2 opposite and a 5 adjacent, so and we're asked to find the sine of 2 theta. So knowing our double angle formulas now, right, I'm just going to go ahead and write this out as 2 sine of theta times the cosine of theta. So let's go ahead and fill this in, right? So 2. So what's my, I'm listing, okay, so let's go ahead and find hypotenuse. Hypotenuse equals c squared, right? So we have 4 squared plus 5 squared equals to c squared. 16 plus 25 equals c squared. This is like some ugly number. Okay, this is 31, 41, 41. Yes, it's 41 equals to c squared. Square both sides, and square root 41 is our final answer. So this should be plus or minus, but it's hypotenuse. Hypotenuse is always positive. So let's go ahead and just erase that. So it's square root 41. Wow, we're working with a banger here, I guess. So sine. So opposite over hypotenuse. So we have 2 square, or parentheses, 2 over square root 41 times cosine, which is 5 over square root 41, close parentheses. So let's go ahead and do this. So multiply across, we have 10 on the top, and the radicals cancel out, so we're left with just 41. And then this multiplies the top, which is just equal to 20. Oh my God. So this is 20 over 41. So that's part A. Part B is now asking us to find the cosine of 2 theta. So using that formula I just wrote out, so we have cosine squared of theta minus the cosine, or the sine squared of theta, right? So let's go ahead and do this. So cosine we found was what? 5 over 41. 5 over 41, radical 41, sorry. Squared that, minus the sine, which is 2 over square root 41. Go ahead and square that, right? So let's go ahead and do it. So when we square, we always we square the top and bottom. So this becomes 25 over 41 because the radical cancels out with the exponent, right? So this is 25, this is 4 over 41. So 25 minus 4 gives us 21. 21 over 41. So let's go ahead and double check our answers here. This is question number 15. 29, what in the world? Oh my God. Okay. Wow, I'm stupid. Jesus. Okay, so I wrote out 4 squared here. This is wrong. It's not 41. This is 2 squared. This should be 4. This is 29. So it's 29. So, okay. So all the 41s I wrote out here should be just 29. So let's double check that again. So part A is equal to 20 over 29, and part B is 21 over 29. Cool. Okay, so now we're going back to like domain questions. Okay, so this is gonna be I'm gonna knock out a bunch of them. So this is number 18. So we're given solve the following equation in the interval 0 to 2 pi, 2 cosine x minus radical 3 equal to 0. So how do we start this off, right? Like as like any other like factoring question, we just move everything over. That's not like the function itself, right? So let's move our good old radical 3 over. So this is 2 cosine x equal to radical 3. Go ahead and divide the whole thing by 2. Cosine x is now isolated. So we have this. So it's basically asking what angle is equal to cosine squared 3 over 2 in the domain of 0 to 2 pi. Right, 0 to 2 pi. So let's think of it, right? So if I write out cosine 3, 2, 1, right? 3 means what? This is pi over 6. So pretty much the intervals of pi over 6, where are they positive, right? So x equal to pi over 6 because he's positive there. Or I guess I could draw a unit circle, right? So cosine is positive in quadrants 1 and 4. So what's the pi over 6 equivalent in quadrant 4? It would be 11 pi over 6, right? Boom. So this question is just 6. X is equal to pi over 6 and 11 pi over 6. Okay, so moving on to number 19, we have solve the following equation in the following interval. So we have 2 sine squared x minus sine x minus 1 equal to 0. So this problem is a little bit, it's a little more challenging. This is like just factoring like a normal like equation or a function, right? So imagine sine is like x instead, right? So like I write this out as like 2x squared minus x minus 1. Yeah, that makes more sense. So like here, I can just factor out like 2x here, like coefficient here, right? And then this has to be x, so 2 squared x. So this has to be 1. So it's like this, right? This kind of format. So, but now I guess, so since I changed the sine squareds into x's, I change it back to like sines. So like, this is like 2 sine x plus 1, like this. And this is sine x minus 1. If that makes it any more clear, like we went, so sine to x and then sine back to x. No, sine to x, x back to sine. So here, we just kind of like set each parentheses equal to 0. So this is 2 sine x equal to negative 1. Sine x is equal to negative 1/2. And here I do sine x is equal to 1. And then now we find out the angles that equate to whatever this is. So here I'm asking what angle is sine equal to, or what angle is sine at 1/2, right? So if we know that it's sine 1, 2, 3, right? So this 1/2 is like this some equivalent to pi over 6. So on the unit circle, right, what quadrants equate to some sort of negative sine value? So this has to be quadrant 3 and quadrant 4. So knowing that, right, what pi over 6 derivative falls in 3 and 4. So this has to be 7 pi over 6 and 11 pi over 6. This is that. Okay, so and then here it's asking what angle of sine is equal to 1. And within 0 to 2 pi, there's like one place, which is pi over 2. So now we combine all the angles we just found all into one thing. So I had here 7 pi over 6, 11 pi over 6, and pi over 2. And that's number 19. All right, so moving on to number 20, we have solve the following equation again. So we have cosine squared x minus 2 cosine x equal to 3. So here, right, I know usually we want to isolate things, but here we want to move everything into one big thing. So I'm going to go ahead and write this out again. So cosine squared x minus 2 cosine x minus 3 equal to 0. So similar to this guy, right, or to number 19, how like I factor everything like in terms of like x and stuff, right? The same thing goes here. Imagine this is like x squared minus 2x minus 3 instead. So like cosine just becomes x, right? So this is a little more easier to digest. So here I just want to factor out something that looks like this, right? X squared. So what two numbers give me -3 and add up to like -2? Well, this would just be -3, and this is +1, because if I do that, I get -3 plus 1, and then I get -2. So here I'm going to revert back to cosine. So this is cosine x plus 1, and this is cosine x minus 3. So let's go ahead and set each thing equal to 0. So this is cosine x equal to -1, and this is cosine x equal to +3. I'm going to go ahead and cross this guy out because there's no possible way to get like a value of 3 within the unit circle unless we like expand it out, but that's like at a later time, I think. So here we're left with just what? Cosine x is equal to -1. What angle gives me a -1 for cosine? Within 0 to 2 pi, and there's only one angle for that, which is x is equal to pi. All right, and so for the last question I'm going to do, this is from chapter 10. This is question number 1. Okay, so it's giving me solve the triangle with, they gave me angle A is equal to 42, angle C is equal to 96, and side C is equal to 12. So this triangle isn't really made to scale. It's just a triangle, right? Basically, this is law of sines. Law of sines. It's essentially just proportions. Like we're setting each thing equal to proportions, and like we'll figure it out on calculations and stuff. So they gave me one pair already. So for law of sines, we do like sine of the angle, right? So this is sine 96 degrees over the side that I have. So they gave me 12 equal to the sine of whatever angle. So this is 42. So they gave me angle 42, and I want to find side A, right? So I have little a here. And now I cross multiply, so I have little a times sine 96 equal to 12 times sine of 42 degrees. So in order to isolate little a, I do a is equal to 12 times sine of 42 degrees all over sine of 96 degrees, right? So that's little a. So let's go ahead and find angle B though. So angle B can be found from 180 minus 42 degrees minus 96 degrees. So this leaves me 84. 84 minus 42, and I'm left with 42 actually, 42 degrees. So angle B is equal to 42 degrees. Let's go ahead and find angle or side B now. So side B can be found, so I always want to use what they give me at first. So I'm going to go ahead and do 96 again. 96 over 12 is equal to the angle of little big B, I guess. This is sine of 42 degrees over little b. So again, little b times sine 96 degrees equals to 12 sine of 42 degrees. Let's go ahead and isolate little b. So this is 12 sine 42 degrees all over sine 96. So pretty similar, actually they are similar, because it's 42 degrees here, this is also 42 degrees. So that makes sense. Cool. All right, so with that being said, this is my rundown of like exam 3 review. This is kind of challenging, not gonna lie. The most complicated part was like the sine stuff I just did, like the factoring. That kind of takes a lot getting used to. I didn't even see it at first, so I would say practice on that. Everything else should be derived from these formulas. I'm gonna pray to God they give you the formula sheet. So yeah, I mean, if you know the formulas, you should know everything else, I hope. This is pretty simple, law of sines. Know how to draw triangles, I guess, or learn how to use context clues to know where. Yeah, with that being said though, that's pretty much it. Best of luck to you guys. This is gonna be rough. Peace.